Hi, good morning. Today theorems able test is very important for annual examination point of view. Question ಕೇಳ್ತೀನಿ. State and prove able test ಅಂತೆ. So statement is like this. Statement. But ಎರಡು ಫಂಕ್ಷನ್ ತಗೋತೀನಿ. If integration of a to infinity f of x dx is convergent at infinity of any real line, it is a is any real line to infinity between this area of this function, so that is convergent at infinity. It is improperty law first time. So statement is like this: if integration of a to infinity of x dx is convergent at infinity, and second function g of x is bounded. When we say that function is bounded, the bounded above and bounded below. The function is bounded above and this function is bounded below, like this. This is f of x, any function of this. We choose it is this. This area part is called it is bounded. So this is bounded above, this is bounded below. So function g of x is bounded. So it is g of x. Clear? So it means definition is mod of f of x is less than or equal to k. This is another definition of bounded. The function g of x is bounded and monotonic. When you see that function is monotonically increasing and monotonically decreasing, that's we want the sequence, right? So using that concept, so this is monotonically increasing, this is monotonically decreasing, monotonically increasing and decreasing. This is monotonic. So g of x is bounded and monotonic. Then product of two functions a to infinity f of x into g of x dx is also the function f of x is convergent with the product of two functions is also convergent because our function is bounded. So is convergent at infinity. This is the theme of Abel test. Clear? Okay. Proof. Now here proof ಮಾಡಬೇಕಂದ್ರೆ ಮೂರು ಸ್ಟೆಪ್. ಗಿವನ್ ಡಾಟಾ ಸ್ಟೆಪ್ 1, ಸ್ಟೆಪ್ 2 ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕಂತ ಬರೀಬೇಕು. ಸ್ಟೆಪ್ 3 ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕು, ಗಿವನ್ ಡಾಟಾದ ಕಾನ್ಸೆಪ್ಟ್ ಏನು ಅದರ ಮೇಲೆ ಪ್ರೂವ್ ಮಾಡ್ಕೊತ ಹೋಗಬೇಕು, ರೈಟ್? ಸೊ ಗಿವನ್ ಏನು ಕೊಟ್ಟನ, ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ a to infinity f of x dx is convergent at infinity, and function g of x, second function g of x is bounded and monotonic. That is function is bounded means g of x is less than or equal to k for all k any real numbers. Then the given button ಮತ್ತೆ ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕಂತ ಹೇಳಿ ಅದನ್ನು to prove integration of a to infinity f of x into g of x dx is convergent at infinity. So ಇಷ್ಟು ಬರ್ಕೊಂಡ್ರೆ ಇದಕ್ಕೊಂದು ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ ಡೆಫಿನೆಟ್. To prove a to infinity f of x gx dx is convergent at infinity. ಈ ಥಿಯರಮ್ ಪ್ರೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ಸೊ ರೈಮನ್ ಇಂಟಿಗ್ರೇಷನ್ ಹೋಗಬೇಕು ನಾವು. ರಿಮಾನ್ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಆ ಟಾಪಿಕ್ ನಿಮಗೆ ಹೇಳಿಲ್ಲ. ಸೊ ಅದೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ತಗೊಂಡು ಈ ಥಿಯರಮ್ ಪ್ರೂವ್ ಮಾಡ್ಕೋಬೇಕು, ರೈಟ್? ಸೊ ದಟ್ ರಿಮಾನ್ ಇಂಟಿಗ್ರಲ್ ಥಿಯರಮ್ ಆಫ್ ಕಾಚಿ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಥಿಯರಮ್. ಸೊ ಲೈಕ್ ದಿಸ್. So next step is very important. To prove this by using Cauchy second mean value theorem. ಇದು ಯೂನಿಟ್ 2 ದಾಗ ಐತಿ, ಪೇಪರ್ 1 ಯೂನಿಟ್ 2 ದಾಗ ಐತಿ. ರಿಮಾನ್ ಇಂಟಿಗ್ರೇಷನ್ ಕಾನ್ಸೆಪ್ಟ್ ಬರ್ತೈತಲ್ಲ, ಅಲ್ಲಿ ಬಂದಾಗ ಅದನ್ನ ಡೀಟೇಲ್ ಆಗಿ ಥಿಯರಮ್ ಪ್ರೂವ್ ಮಾಡ್ಕೊತೀನಿ. ಬಟ್ ಈ ಥಿಯರಮ್ ಪ್ರೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ಆ ಥಿಯರಮ್ ಹೆಲ್ಪ್ ತಗೊಂಡು ಪ್ರೂವ್ ಮಾಡ್ಕೊತೀನಿ. ಸೊ ವಾಟ್ ಈಸ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ Cauchy second mean value theorem. So statement is like this: the integration of t1 to tt. So f of x into g of x dx, that equal to area of this second function g of t1 integration of area of t1 to epsilon between t1 to 2 there is a real number, so I can choose the number epsilon. So into f of x second function into dx plus g of t2 t1 I to t2 g of t2 integration of epsilon to t2 f of x into dx. Clear? So this is the statement of Cauchy second mean value theorem. Cauchy equation 1. ಇದು ಆಮೇಲೆ ಡಿಟೇಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ. ಇದನ್ನ ಎಷ್ಟು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. g1 g2 ಹೊರಗಿರ್ತವೆ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಫಂಕ್ಷನ್ f of x between t1 to t2 there is an epsilon. Clear? Okay. To prove this, sorry, ಇದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? apply modulus on both sides. ಇದಕ್ಕೆ modulus apply ಮಾಡ್ಕೊತೀನಿ. So because of function is bounded, so that's why g of x is bounded. So integration of t1 to t2 f of x into g of x dx, so that equal to integration of g of t1 integration of t1 to epsilon f of x into dx plus g of t2 integration of epsilon to t2 f of x into dx. So modulus like this. Those two x are the togoni plus other plus it is 1 using, so directly I can write like this, which is less than or equal to modulus of g of t1 integration of t1 to epsilon f of x dx modulus plus modulus of g of t2 integration of epsilon to t2 f of x into dx. Right? Because using this concept x plus y, modulus of x plus y, addition of two real numbers should be less than or equal to mod of x plus mod of y. Using this concept I can apply this. Clear? Those two x anta tagondidre y anta tagondini, then so which is less than or equal to modulus of g of t1 into the function modulus of integration of t1 to epsilon f of x dx plus modulus of g of t2 modulus of integration of epsilon to t2 f of x dx. Right? Call this equation 2. Is it clear? This part up to this between x sign change agilla antandre because of mod of x into y, product of two real numbers that equal to modulus of x into modulus of y. Using this base I can write it as this. Clear? Okay. So between this I can choose, this is a real line, this is a to infinity a0, between a to infinity I can choose it is t1 to t2. Using this area I can write like this. This function, this is g of x is bounded, I can choose it is, while substituting this value should be strictly less than. So total ಆಗಿ ಎಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಎಪ್ಸಿಲಾನ್ ಬರಬೇಕು. ಎಪ್ಸಿಲಾನ್ ಬಂತಂದ್ರೆ that function is bounded, means chosen value. ಎಪ್ಸಿಲಾನ್ ಬರಬೇಕು, ಇದನ್ನ ಟರ್ಮ್ಸ್ ಅನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ಕೋಬೇಕು. Means I can choose like this. K by 2 it is epsilon by k, but it is 2 times of epsilon by 2 plus epsilon by 2, it is epsilon. Okay. Choose any real numbers, I can write like this. It is k into This one is epsilon by 2k plus this is k and it is epsilon by 2k. K will get cancelled. K is any real number. For all x is greater than or equal to k, I can write it is this epsilon by 2 plus it is epsilon by 2. Epsilon by 2k na ತಗೋಬೇಕಂತ ಏನು ರೂಲ್ಸ್ ಇಲ್ಲ. ಇಲ್ಲಿ 4k ತಗೋಬಹುದು, 6k ತಗೋಬಹುದು. ಬಟ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ epsilon ಬರಬೇಕು. ಇಲ್ಲಿ ಬೆಲೆ ಕೊಡಬೇಕು ಮತ್ತೆ ಟರ್ಮ್ಸ್. Right? Means you have to choose that area between this. This is function. So it is this. This is f of x. This is g of x. Between t1 to t2, this is an area I can choose. It is this. Right? So this is epsilon modulus of integration of t1 to t2 f of x into g of x dx. It is less than. This shows that function is bounded. Therefore, modulus of g of x it is less than or equal to k means it is bounded. It is bounded. I can write like this. Therefore, it is convergent. Means integration of a to infinity f of x into g of x dx is convergent at infinity. This is the theme of Abel test. Practice ಮಾಡಿ ಬರ್ತದೆ.